Hi and welcome back. This is part 2 of the MDriven Designer walkthrough. I think we just continue where we left off. So there's one additional type of diagram that I haven't shown yet, and you get to this by double clicking on a class, not on the name, because then the name will enter edit state, but beside the name. And this type of diagram is it's an automatic generated display of the class, its attributes and its relations. So from here you can navigate to the other existing classes that it has relations to, associations. So this is another way to walk around your complete model. It's here you see everything in the repository, and you're not able to hide anything from view or anything like that. So this is the full repository graphical display, so to speak. If you select a relation, you get the properties. If you select a class, you get the properties. Whenever you select a class in the circle around the center class, it will navigate to that one, and you can select an attribute and get its properties. What I think I forgot to say about properties is they should have a type. I said that, but the question mark behind the type is the C# syntax to denote nullability, that it's able to have a null value. In MDriven we call this allow null. So the allow null property is true, and it's rendered as a string question mark. If we were to change this to false, the question mark would go away. So allow null is equal to the question mark behind the type. The state attribute, having this icon on it, let's go back to the state diagram. Once in the state diagram, we can see that the state attribute is state. We can also see it here, house state, and we can change this name if we would like to. We can give the state diagram a category and color on new states, if that is something that we want to do. But besides that, so this is a house, maybe a state diagram for a house would be that we plan to build a house, and then there is a construction phase. And after that there's a maintenance phase. And finally, in this state machine, there might be a demolition phase. So depending on what dynamics you would like for your class, you can describe them in a state machine like this. Of course, during the construction phase, there might be additional sub states. So we could add a region to the construction phase and say that there's a state in this region that is groundwork. And another state that is building, or rather exterior, no, let's call it building. So whenever a house is created, it will start in this state, but since there are no guards stopping it from going this way, it will end up in plan. But we will need a trigger to take it further. So I'm gonna add a trigger called start construction. And what happens then is we end up here, and we need a start state for the construction for the inner region. And we say that the first thing whenever we enter construction is to go to groundwork, and after that we could go to building. And my idea about what this actually means is that we start building the house. This is just preparing the groundwork. So, and this trigger we will call start, or rather construction done, we might call it. And I would call this one for demolish. I also need a trigger for this one, start building, something like that. So you can make these state machines as complex as you need, or as simple as you need. They are just rules, really. So maybe there is something that you need to do before start construction. Maybe there's a domain rule that needs to be fulfilled. We can have these in guards. So maybe you need to have the address, and the address must not be null, I guess. The language I use here is OCL, Object Constraint Language, and we will use this throughout defining our model. So in order to start construction, we need an address. The fine thing about OCL is that it really uses the language from our model a lot and just add a few operators to work on the information that we have defined in the model. This means that if we take care and do a good model and design things according to what we actually want to call them when we speak about these things, the rules get really easy to read. So in this case, the address should not be null in order to be able to start construction. So, and heading back to the house class, we see that the triggers that we added has been added as methods on the house class. This is one use of methods on the class, but we could just as easily add another method that isn't a trigger. It doesn't have the symbol TR for trigger, and we could implement this saying that it should have a return type of type string. It should maybe have some parameters that we send in. Let's let it have a param1 of type integer, comma, another param of type integer as well. Now I can implement what the logic in the method should be. Again, OCL, but in this flavor we call it action language, because when we're using methods we are allowed side effects. We can change data. So maybe this method should just take the param1 and sum it with add it to param2, and then we see that param1 and param2 returns an int32, an integer, but the required type as we defined our method was string. So we could take the result from this and state it should be a string instead. And it's 2 s's in as string. So then we get a green light, and that is okay. But maybe it would be better in this case to leave it like that and instead change the return type to integer. And if we now check that, we see that it's green, and this system integer 32 is the return type, and the expected required return type is also that, so that's fine. Say that we have typed something wrong here, like an X behind this, and we see that this is wrong. And if we were to save this model, we see that we have an error. We have an error in method house, method 1. That param2x is not a type name. It's not recognized. So we should fix that and save to see that we don't have any errors. So that's one way to add logic to your definition, to your model. Of course, we haven't executed anything of this as of yet. We're just defining it. We're just designing it. If I now switch back to a diagram, I can see that the methods that were created, the trigger methods and my method 1, was added to this diagram as well. So now we have shown a little bit about the definition and how you could navigate around your designing of the model. What if we were to press play? And what does play imply? Play brings up a system prototyper dialog. The first step is that we should select persistence. Persistence is where data is stored. Let's choose none for now. That's the easiest one. There's no configuration for this persistence, which is step number 2. And step 3 is actually start a system running our model. So we will start that one. And then we have a few options. I'm gonna go with the new debugger to execute the definition that we have in the model. So I get this window. After this, I can't actually get to my design surface because the prototyper is model. I can close the prototyper and still have the debugger available. So what we can do in the debugger is to again write OCL expressions. So if we were to just press edit, we get the same OCL editor as we've seen before. And let's see what happens if we pick the class house. And we should find some operators on this. A create operator. Actually, we can't find a create operator because we are in OCL, and OCL doesn't have side effects, and creating something is a side effect. It changes data. So my mistake. Another operator that's commonly used in OCL is to bring up all the instances of the type house. So let's go for that. House all instances. And execute. And then we get a result list, which is empty. And we get all the attributes that we had in the house class. So we need to be able to execute some action language. And as is written up here, we can prefix a row with the OCL colon or action colon or OCL PS colon. And the action colon is actually to state that the expression should be action language instead of OCL. So I'm gonna do that now. Action colon. And how the debugger works is that as long as there's an empty line between expressions, the debugger will think of it as a separated expression. So execute will just execute the thing that you're at, the thing that you're on. So this will execute this expression, but not this expression. So if I enter edit again, I see there's a I can now go for the house again and the operator. I see there's stated OCL up here. How come? Didn't detect my... That might be a bug actually. action editor. Now create, there's an operator. Whenever in the OCL editor I can press Control Enter, and then I get a code completion type list, and I can pick that one to quicken my typing. So if I were to execute this one, nothing much happens, except there's a new row in the result set which shows all instances. So all of a sudden there's a new house, and well, that's good. We see that the state of the house is plan, and that's according to my state machine, that it should go to plan initially, like that. So that would imply that I can let's get a handle to this house, selected to M1. Here I see a list of variables, M1, so there's a quick way to access M1, M2 and M3. It's just for memory 1, memory 2, memory 3, like on a calculator. And now when I marked a row and said selected to M1, I get M1 is a collection of house, because this was a house and it has one item. And so on the M1 we can maybe perform a trigger edit. Let's see, M1, that's a collection, so we want to reduce it to the first object, and that's not a problem because there's only one object in this list. And then we will want to do the operation, which my state machine says is start construction. Start construction, and I press Control Enter to get up this start construction. Okay, so if I were to execute this now, I shouldn't be able to get here because this guard isn't fulfilled. Let's see what happens. Maybe we need to check M1 first. Address is null. I wonder. Execute. Not null. Execute. This is what happens. The address field, even if it was nullable, it was not null. It was apparently an empty string, which is very similar to a null, but it's not a null. So maybe we should change our rule to be address, and there's an operator from, oops, wrong keyboard. There's an operator from C# is null or empty, which is usually good to when you're checking strings, is null or empty. And we want to make sure that it isn't. So I add a not in front of the Boolean result. So that's my rule instead. And that doesn't really help me much here because this works on the model that I had when I started the debugger. But what I can do is to reread the model, starting everything over. Now it works on the model that's here. So if I execute the house all instances, you see that I have no houses. That's because the persistence that we chose to use was none. So it remembers nothing when we start over. But that's easily fixed. I can just create the house again. And now I have it and it's planned. And now I try to start the construction. But I forgot to initialize M1 to be the selected house, one house. Start construction. And now it says unable to find a transition for trigger start construction from state plan. Well, it should actually have said unable to find a transition, a valid transition, because for each of these transitions there's also a check that's denominated with the question mark behind it. So am I allowed to use this trigger? And here it returns an empty box, not checked, which denotes false. So I'm not allowed to walk this this way in the state machine. The business rule prohibits it. Can I then update or set the address? Well, that's something that is a side effect, of course, setting a value. And then we need to be in the action language. Make this a little bigger. So, and how do you assign a value in action language? There's an operator starting with a colon and equals. So those of you who have been working with Pascal or Delphi or something like that will recognize this. This is the assignment operator, colon equals, to separate it from a simple equal, which is just equals. But this is assignment, and we want to assign it to a string. So, and it shouldn't be empty, it should be an actual address. So where I live is Gråstensvägen, like that. So that's a valid expression, and I would execute that. Am I allowed to start construction? Yes, I am allowed to start construction. Good. So if I watch my house and I start construction, I immediately enter the construction outer state, and in turn this ends up in the start state for the region 1. And since there's no guard on this one, it will end up in groundwork. So I'm in construction dot groundwork. Okay, so very briefly we have seen how to define rules and a model to work on, and how to actually create data according to this model following these rules. So the engine that runs this debugger is the engine that will be behind any MDriven system in the end. So it's a runtime part of the MDriven framework that for turnkey is situated on the server, on the web server, and for let's say a fat VPF client or a thin client on Android, you will have the same engine, and this engine will mainly watch your model and make sure that you follow every rule that you have defined in the model. So that's really the main thing that separates what the MDriven catalog of products do compared to other UML designers. That we have this engine that actually executes the model. And the idea is that if you execute the model, then you actually do not need to have someone following the model with ordinary program code, because then the engine will follow this in runtime. And the engine never gets it wrong. It just follows the model exactly. And since you can model anything, and I want to stress this, sometimes people say to me that, well, you can't model everything, but that's a misconception. You can. And you should. But you should only model things that are important to your business, because modeling is all about doing a model of reality, not doing reality. And the model will help you to understand and cope with reality, not replace reality. So keep that in mind, that you need to have a clear goal with what you want to achieve in order to be able to model. Otherwise it would be hard to know what is important for your model. Okay, enough about that. What we have shown here is that it is really fast to jump between the engine that executes the model and the actual model. And this is actually a very good thing, because it will help you to get your model right. In this auto-generated diagram, we also have cross-references, so you can find all the diagrams where the house class is available. If we were to go to class 1, we see that it's only available on diagram my first. So if I click that one, I get that diagram. I'm gonna save this here, and if I were to remove these attributes, because now I actually delete them, so they disappear from the repository as well. Now I delete them anyway. Like this. Delete. And I'm gonna save that, and if I reread the model and execute all instances, I see that the attributes are gone. So it's a quick way to verify that your ideas that you have in your model actually are followed in real life. And this is of course just a simple way to execute the model, and the engine will allow you for a lot more, and we will come to that. So I once said that the engine that we have here is like a software developer made of software. So this software developer gets your specification, that is the UML model, complete UML model, and it follows it by the letter, doing everything exactly as you want, never deviates 1 millimeter. And this gives you rather good effects that no longer need you hold back when you design something complex. You can be very explicit because there's no penalty in implementation. It's all about design. And you as a architect of the system, you own the model, and you can be sure that whatever you can express in the model will be handled by the engine. So don't be afraid. Give it your best shot and really express yourself with this tool. And you will see that the engine will handle it in a matter of seconds to have it done. Of course, this changes the scene for software development when it comes to standard systems. For what is a standard system? A standard system is really a standard model. And a standard model is really something that anyone can do. So that's not really that interesting any longer. You get the effect when you really go close to a specific business and help that business to thrive and reduce bottlenecks. Yeah, enough about that. Pressing the play button brings up the system prototyper that in turn enables you to show the debugger. But we said that there were different kinds of persistence. The XML is just to persist your data in a XML file that you choose on your hard drive. So that's a simple way to keep your data. My data.xml. So if I start my system with XML persistence and I start a new instance of the debugger, this one uses the XML persistence. If I were to create houses, execute, I get a save button, because now the engine has detected that we have objects not saved and that we are in a persisted environment. If I were to select all the instances, I see that I have 3 houses. and I can actually undo the last one, and that one, and that one, or redo. So this is all the engine working on my model and seeing that I created 3 houses, and I might want to undo the actions I did, and it allows me to do that until I have saved. So I can either save or I can cancel the edits altogether. Cancel would mean that all my houses disappear. Yeah. So let's create 3 houses again, and if I set M1 to this, am I then allowed to start construction? No. But if I set the name on the first one, let's see if that took. Yes, there's the name. Am I now allowed to start construction? Yes. Okay, let's look at them again, and let's start construction on the first one. Okay, save. If I now were to, let's close the old one. If I now would change my model to drop attribute 6 as well, and number 4, and reread, the system is restarted, but when I do house all instances, I do get my data back, but it has trimmed the things that doesn't exist anymore from the file. As we dig further into this, we see that there's also an SQL option for the persistence. And the configuration for that is more complex, because we need to define the connection string to the database. We need to be able to create the database, or if we want to keep data and just change with a changing model, we would press evolve, and then we would save the script to the database so the evolve mechanism would work. So that's a slightly more advanced option. The most cool option is the MDriven server, because if we have an MDriven server that runs, or turnkey site that has an MDriven server, we can easily hook the debugger up to that one and see our data from the cloud. But we will dive into that later. So we will get by with the XML persistence for now. Okay. A very important piece to get further with our designs is to collect data in different views. What belongs together? How should a user look at information? How should it be consumed? It's actually when we start to think about this that many of the requirements are easy to understand and easy to catch. So let's do a short introduction of the ViewModel concept. That's the button for bringing up the ViewModel editor. So view models are, I would say, an important part of your complete model. This is how they work. We add a new one, and this one is then called ViewModel 1. And they should really be rooted in a class. So let's say this one is rooted in house. And then it would make sense to call it house view, maybe. Once we have done this, we see that in the repository, under the view models node, we have a house view. The house view has a few properties, but the properties are most easily changed through the ViewModel editor. So what do you do here? Well, actually you define what information that we should keep together for a specific use case. Normally we will be using the placing hints, but just to prove a point, I'm gonna remove them for now. So we are in the context of house. So think of it as if we had a house instance, and then we want to be able to collect information about the house. So let's say that the address field is important, but we also had navigation to the street. So we could add a column for the street position, maybe like that. So these were guided additions to the view model that helped me, because I had said to the ViewModel editor that I was in the context of a house. But I could just as well done a generic column like this, a new column, and the new column doesn't have an expression, and the expressions are made up of, yes, you guessed it, OCL. So what I can do is write self for this is equals to the C#. This self is what we use in OCL, and you have the properties. So maybe I have the address like this, and maybe I will call this column in the view something. Might want to call it address. In Swedish, address is spelled with one D. So now I have a duplicate column, yeah, because I added that one. And I'm gonna rename this to position. And now it gets apparent to me that this isn't really gonna cut it. I want something more. Maybe I don't even want the address on the house as a property, because I had the street. Well, this is what happens all the time when you model, that you think you got it and then you don't. So if the street had a name instead, like this, and the house only had a street number that was integer, like that. Now we have a few errors because we said that the default string representation for a house, or rather, what was it? Default string representation house. This isn't valid any longer. Instead, we should probably go from self to the street as the street, and follow and take the attribute name. So that would be okay, but we would like to append a space and then add self dot street number, but that's an integer, so we need to treat it as a string, like that. So that might be a better default representation for the house. We had a couple of more errors, and let's see if I can get them on screen here, like this. So it says invalid expression in self address is not a member of house in the house view. So if I click that one, I get into the house view and I get to the address. This is not valid apparently. Well, that's the same problem. So I'm gonna put the street dot name. We had some errors left in the guard in the state machine. Yeah, so this isn't valid either. And this is actually what it means to be strongly typed, that whenever you break something, you get full information on what the side effects of that break is. And there's not a problem to fix it, so instead we do the street and that's not greater in that's a relation, and that should not be empty, not empty. What happened to this one? Not empty. Okay. Like that. And if I save, okay. So see what I mean with my statement that when you start collecting the use cases to actually think about what the data should be used for, then it's really easy to see where you haven't thought enough about your model. So this might be one use case where you get the position and the address, and actually I want to add the street number as well, and I find that one here, like that. So that's you might have heard a discussion about model view and view model patterns, and that's a good separation of concerns, keeping your business rules to the model and only section pieces of information for consuming of certain use cases. So you can view at it as each use case should have a specific view model. That way you ensure that you don't overexpose information that just happens to come along with some other information just because it's convenient. That often is the case when you expose a class. Then you get a lot of information and a lot of possibilities. But if you have really thought about the use case, you have reduced the available things from the class, and also, like in this case, followed a few associations to other important details for this use case. And since this is so centric to building views, we have that. Why is it centric? The data in the view needs a view model to fulfill its viewing of data. So the view model goes hand in hand with a use case that goes hand in hand with a view in most systems. So making this even easier, we could add the placing hints to our view model, and that is just that we expose these columns that provide some metadata about each view model column. And the metadata states that where it should be positioned if they were to be positioned in the grid. So show the grid lines. Here's a little grid, and this is how an engine interpreting our view model and our metadata for the placing hints would go about drawing this. Okay. And this makes it easy for us to actually design a few more details about the UI than we would otherwise be able to do at the model level. This isn't actually the UI that will execute, it's just the definition of a way to collect data. Okay. If we reread our model here, and if we select the houses, you see that there's probably, let's restart this one altogether. There were two large changes, I think. Yeah. So one more time, I'm gonna do a new file. So let's create the houses again, like that, and I'll save them. What I can do now is to use the view that I defined in the model to show me the data available according to the view. And I could also have the engine construct a UI based on my view model definition and on the placing hints. So this would be another way to actually set the value. That was a bad example, but it goes to show the address is actually pointing to the street, and we haven't set the street. If I were to set this one, it would stick and the save button would light up. If I were to set this one to anything, it's a string. It's also on the street. So you really got me. What we should do is perhaps head back to the ViewModel editor, state that there's an action in the ViewModel to actually construct the street. So I'm gonna move this so that the menu is on. Add a column prepared for action. So that's a column, and now I get the action language, and then I can do the expression for self, the street assign, and then I create a new street. That way the street object would be available to write in. And the action call, I would just say create street. Having done that, and heading back to the debugger and rereading the model, and it says that you haven't saved what you had. Would you like to save? Yes. Okay. Did I reread the model? And selecting the houses again. Result as root for a ViewModel UI. That one. And now I can create the street. And then I will be able to set the address and the position and save. And if I have another street, I would need to create it some other. Save. And if I now look at street all instances, I see that there are two streets, the ones that I created. Okay, so we're gonna round this off, but before I leave you, I would like to point out that I'll be back. So please watch again. Thank you very much.